Students, welcome to mathematics class. The topic we'll be considering today is matrices. What is the matrices, or what is a matrices, or what is a matrix? A matrix is a set of numbers or elements arranged in a rectangular array or pattern. If this is the first time of you hearing about matrix, or you have been working around or with matrix before, you have done questions in matrix before, this will highlight and give deep understanding of it further. The order of matrix gives its shape in terms of rows and column, but the number of rows is always stated or written first. The number of rows is always what? Stated or written first. Example of matrices are what? This and this type of matrices. We have different type of matrices, but this type is what? 1 by what? 1 by 3. This one you are seeing is the row. That's why we say the row is what? Is written first, is stated first. So when you see such matrices written as 1 by 3, that means this one represents the row and this represents the column. You get it now? So we call this one 1 by 3 column with 3 elements. You can see these are the elements. And we have other example. See, you see, this is another type. This is 2 by 3 matrix with how many elements? We have 1, 2, 3, 4, 5, 6. This is 6 elements, and you can see that in these 6 elements, this is what? This side from this point, column is known or is stated from, represented from this side, from left side to what? To right side. So this is what? This is the column. Why this is what? This why this is what? Is the row. And of course there is a notation for matrix that you need to know. But before we go to that, this is simply what? 2 by 3 matrix with 6 elements. This is 2 by 2 matrix with what? With 4 elements. You understand? But it is also called, this 2 by 2 is also called square matrix. You understand? So the notation that I want you to the first thing that you should know is that we have different types of matrices or examples of matrices that is being determined by what? By their size. The size, I mean, to a matrix only nǹkan tá fi ń determine nǹkan tá dẹ̀ fi ń determine irú matrix tó jẹ́ òní kíni òní size and kí dẹ̀ ni size mean pé kíni row kíni column tó ní, kíni row kíni column tó ní. Tó bá ti rí matrix, nǹkan tó kọ́kọ́ máa wò ní tó máa ń kọ́ òun ni the row side. The first figure you will see, if it is 1 by 3, if it is 2 by 3, if it is 2 by 2, it represents the first digit represent the row, while the next one will represent the what? The column. So number kan tó bá kọ́kọ́ rí ó máa represent the row, number ẹlẹ́ẹ̀kejì tó bá rí ó máa represent kíni o, number ilé, for example this one ilé represent the row, ilé represent the column. Do you understand now? So definitely there is a notation. There is a notation that is essential for you to know, because as we go further it will help you, especially in multiplication of matrix and some other transpose and some other things like that. So this one, since we said that this 5 and 4, they are under what? They are under column. Do you understand now? Why 5 and 0 here? They are under what? Row. So what you need to know first is ARC. That's the notation. This R is what? Is the row. That means row comes first. Why? This is the column. So when you see something like this, A11, this one represents what? Represents the row, the first row. Why this represents the first column? So this is the first column. This is the first row and the first column. Do you understand now? And what figure can we find in first row and first column? Is 5. This is what A21, which is what these 2 represent the row. That is the second row in what? With first column. This one is the first column. So if you move to this side now, you see this is what? A12. A12. So subscript, you see A12. This one represents what? Row, because we are still in the first what? We are still in the first row. We are still in the row. Do you understand? This one, we are still in the row. Do you understand now? We are still in the first row, while this is the second what? This is the second column. Do you understand now? This one, we are in the what? We are in the, like this now, we are in the what? We are in the second row, and we are also in the second column. So that's that about that. So for example, if you are considering this now, this one is what? A11. This 12 is what? A12. And this one is what? A13. This is what? A21. This is what? A22. And this is what? A23. A23. This is A13. Do you understand now? So that is how to represent that. That's how you represent. So let's go further to addition and subtraction of matrices. Addition of matrices. So matrices can be added or subtracted, only there is a condition. Tó bá fẹ́ add the matrix, tó bá dẹ̀ fẹ́ subtract wọn, ó ṣe kí n fẹ́ yọ kúrò, fẹ́ minus. Don't forget, má gbàgbé pé nǹkan tó fẹ́ yọ kúrò, nǹkan tó fẹ́ add, tó bá add the matrix, tó bá yọ kúrò, nǹkan tó ń add ní pé kí ni, nǹkan tó ń add tàbí tó ń subtract ní kí ni, àwọn element tó wà nínú ẹ̀, these elements you consider. So matrix can be added or subtracted if they are of the same order. The same order means of the same size. Do you understand now? Of the same size, like 2 by 2, 2 by 2. If you have 2 by 2, 2 by 2 now, they have the same order. Do you understand now? That's the order. They have the same order or the same size in terms of rows and their columns. So they have to be the same order, and the result they will produce by the time you add or you subtract, you do what? You also give what? They will produce that same order. If it is 3 by 3, it will still give you 3 by 3. If it's 2 by 2, so let's go to example 1. Let's go to example 1. You can see if A is this matrix having these elements, what type of matrix is this one? You can see is what? Is 3 by what? 3 by 2. This is the row and this is the column. You can see it's 3 by 3. You understand? 3 by 3. And how many elements do we have there? We have how many elements? Elements we will learn in 1, 2, 3, 4, 5, 6, 7, 8, 9. We have 9 elements. And also we have matrix B, that is having what? That is also 3 by what? That is also 3 by 3. So don't forget about the notation that I told you of. This is what? A11, A1, A21, A31. Do you understand now? This one is what? A12, A1 what? 3. Do you understand now? This A22, this A23, this A31, this is A32, this A33. You understand? Those are the notation for it. So, and the question says that we should show that A plus B is equal to what? B plus A. Well, what do we need to do? Kí la nílò láti ṣe? Ó ní pé àwọn element kọ̀ọ̀kan with respect to their row. Don't forget that you can only add or subtract matrices that have the same order, that have the same row, the same column. Do you understand now? So what do? We have 2 plus 3. Do you understand now? Will give us what? 5. That's why we have 5. This 3 plus minus 1 will give us what? 2. Do you understand now? That 0 plus 2 will give us 2. And 4 plus 1 will give us what? 5. Why? 2 plus 3 will give us 5. And 1 plus 1 will give us 2. We have 3 plus 4 will give us 7. 1 plus 2 will give us 3. And minus 2 plus minus 1 will give us what? Minus 3. Do Do you understand that? Make sure you follow those negative and positive notation very well. So now see b plus a. There is difference between a plus b and b plus a. Depend on the element involved. Do you understand now? So that means b will come here, b will come, matrix b will come before a. So let's see, 3 plus 2 will also give us what? 5. Minus 2 minus 3 will give us what? 2. Why 2 plus 0 will give us 2. 1 plus 4 will give us 5. 3 plus 2 will give us 5. 1 plus 1 will give us 2. 4 plus 3 will give us 7. 2 plus 1 will give us 3. Minus 1 plus minus 1 plus minus 2 will give us minus 3. Therefore, we see the result here. The result for a plus b is the same thing with what the result for what? Because at a11 we have the same value. We have here, we have the same value. We have here, we have the same value. So that is how you get to know they are the same. So from the above result, a plus b is equal to what? B plus a. Question 2. Subtract b from a. If a is this matrix and b is this, so we have to subtract. What do we need to do? Don't forget this statement. Is it subtract b from a? That means a is the first matrix you are going to write, then you subtract it. You subtract b from a, so that will be a minus b. You understand? So the first matrix you need to write is a, which is 2, 3, and don't forget that subtract. Before you can add and subtract, it has to be of the same order, the same row, the same column. So if we have that, so we have 2 minus 3 will give us what? Minus 1. You understand? Why 3 minus 1 will give us what? 4. And 0 minus 2 will give us what? Minus 2. 4 minus 1 will give us what? 3. 2 minus 3 will give us minus 1. 1 minus 1 will give us 0. 3 minus 4 will give us minus 1. 1 minus 2 will give us minus 1. Minus 2 minus 1, that is minus 2 minus 1 will give us what? Minus 2 plus 1, which will give us what? Minus 1. Give us minus 1. So don't forget this, the basis of matrix, and we are going to be considering the multiplication in our next class episode. We're going to be seeing how to multiply constant, that is constant with matrix, that is scalar multiplication. We are going to be seeing how to use matrix to solve word problems, and also we are going to be considering the multiplication of matrices, the transpose of matrices, and some other aspects of matrices. Keep reading, keep studying, keep safe. Bye.